Okay, let's slowly start our webinar today. First of all, well, we're talking about navigating post-training for coding LLMs, and we have a wonderful panel today. I would like to welcome Aleksei, Petrov, Nikita, Pavlichenko, Boris, Yangel. Guys, thank you very much for joining us today, finding time to share your views. So, yes, sorry. So Aleksei is a founding engineer at Poolside. You might have heard this name. The guy's been all over the news in the last couple of months. Boris Yangel is head of AI and research and development at Nebius. Guys are doing some wonderful job in there. I've been working closely with them for several months. They're doing a great job. And Nikita Pavlichenko, who is a senior ML engineer at JetBrains, and as I understand, he is involved in developing an AI assistant, JetBrains' own AI assistant, but they're going to talk about this more in a second. So again, thank you guys for being here. So our agenda for today going to be as follows. It's not a strict agenda, but we're going to try and stick to this. So we're going to start with well, a round of introductions. You're going to guys talk about your projects that you're doing, but then we're going to go into the benchmarking, what benchmarks you use for your specific tasks, and how do you measure the performance of your models. Then we're going to deep dive into the most interesting bit about the post-training of the models that you have. We're going to talk pipelines, methods, and data. Then we're going to look into the future. We'll be interested to hear your thoughts about how the market's going to change, how the model is going to change, and we'll leave some time for QA at the end. Hopefully, we're going to have some questions. So at this note, I'm going to come back to the slide with you guys. So Alex, if you can start, please. Can you share with us what sort of task are you involved in? What sort of task you're trying to solve? Briefly describe, is it an agent system? Is it a single LLM, or is it an ensemble of models? Are you building a model from ground up, or you're using open source models? And what is probably the main challenge that you face in your day-to-day work? Thank you.
Hi, everybody. Thank you, Konstantin. Thank you for such nice introduction. Yeah, I'm working at Poolside. At Poolside, we're building state-of-the-art models and a product for code assistant integrated in different IDEs for large enterprise companies like banks or consulting companies, etc. And at Poolside, I'm working on post-training stage of our chat model. We have different models for different tasks. My main job is development of the chat model, working on my input is base model after pre-training. Then we utilize all our pipelines, and in the end we produce this final checkpoint, final model that in the end works and being served inside extension. So yeah, all in all, it's quite similar to classic LLM project, meaning that yes, we have our own pre-training. We have a large GPU cluster, so we pre-train our own models with all the abilities to work good on some different various tasks with code, like code generation, code classification, code translation, and understanding, and etc. So I would formalize this in the following way. So first of all, our model is a part of IDE extension, and its main scenario is code generation. So it should be able to generate correct code, work robustly, and etc., etc. But at the same time, it's still kind of classic LLM, which may serve many other miscellaneous scenarios, like questions about some CLI tools, or like how would I do this and that, or like I'm getting this error from my project, help me find the bug, etc., etc. Yeah.
What is the main challenge? Thank you for this. What is the main challenge that you face right now?
Yeah, the main challenge is still that models, even like state-of-the-art models, they are quite, I wouldn't say they're quite bad with code. No, they're quite good, and with like I think like Copilot and other products already prove that LLMs are already pretty useful for day-to-day tasks for software engineers, but still, for my opinion, we are all like an industry. We're all in the very beginning of our path, and I'd say the main challenge is to tackle real life complex software development tasks like repository level scale when it's not something like lead code or like Olympic programming tasks, but it's more like feature engineering, debugging, or something like that. So making a model that can not, first of all, it can understand these very large and usually specific context of a given repository and task, and in the end, being able to understand what solution might look like, and in the end, implement such solution, editing multiple files in the repository. Yeah,
Great. Thanks very much. I'm sure we're going to dive deeper into these issues later on today. Boris, the same question for you. I'm going to repeat briefly. So what is the task that you're trying to solve? Are you building the model from scratch, or are you using open source models? You're fine-tuning them. Briefly describe what does the system of your model look like, and what is the main challenge?
Sure. I guess first, hello everyone. It's great to be here in such an amazing company. And before I describe the task, just to give you like a little bit more context. So I guess some of you don't know what Nebius is, the company that I work for. It is basically a cloud for AI builders, providing computing infrastructure for people training their own models and doing inference of them and so on and so on. And the AI R&D team that I lead has kind of a twofold mission. We kind of do our own applied research using the spare compute that Nebius has, like exploring things that might potentially turn into new products for the company, and at the same time kind of dog food our internal infrastructure to make sure everything like actually works. You can actually like do research and train models using our cloud so that our clients get like the best they can. And the reason I'm here today is that one of the things we've been looking at recently is language model agents for software engineering. And for those of you who don't know, it's like a relatively new paradigm of how language models can be used for automating software engineering. It is different from like code completion in IDE or chat assistant, which you can like ask how I can implement a particular feature. So the idea with agents is that it is some kind of autonomous system that you give a container with a development environment. You give a textual description of what you need to do, like what feature to implement or what bug to fix. And then this agent, usually based on a large language model, will go into this container and study the code, try to modify, try to run tests and iterate on it until it gives up or it is satisfied with the solution it got, at which point it will give you back the patch saying, okay, here's what I think solves the issue. So we believe this systems will be very important for the future of software engineering, and we've been looking into how to build better such systems. In particular, like one project that we have, I think just last week published some results on is how to use test time compute to improve such systems. Basically, what people mostly do with agents these days is they work on what we call scaffolding, which is like the code that orchestrates the LLM calls, like when to do what, whether to run tests, whether to reproduce something, and so on and so on and so on. And it is usually kind of helpful to work on these things in short term, but long term they never win due to something called bitter lesson. What wins is something simple, robust, that scales with as you pour more compute into the mix. So one example of such method is search. And basically what we've been doing is studying how search methods also known as test time compute methods, can be applied to such systems. I guess I'll stop at that, and later I can give you more details about it.
Thank you, Boris. But what is the main challenge that you face to close on the introduction?
Oh, I mean, there are so many, and I would be happy to talk about them in more detail. But if I have to pick one, it is, I guess, working with these things at scale. Because so when we talk about these agents, we talk about actually running commands inside some containers or virtual machines. And when you do this at scale, you have like 1,000 containers where you do things, and so many things can go wrong. Like containers can go out of memory. You can run some command that will sort of time out infinitely, and you have to watch for these things, like retry these things, and make sure that when you run a 10,000 kind of job on cluster, it just works and nothing fails, and it's so much pain.
Thank you. Thank you very much. And last but not least, Nikita, the same set of questions for you. Task you're trying to solve, briefly describe what the project looks like from the inside, open source model, so ground up, and the main challenge.
Sure. Thank you, Konstantin, for inviting me. And I work at JetBrains, and we at JetBrains develop a product called AI Assistant. So, and it's actually cool that we have, I think, 3 persons working at different parts of kind of the same, very similar stuff. So we also have like a chat interface and some AI actions in the IDE. But I specifically work at the team that develops the code completion for JetBrains IDs. So you type some code, and the model suggests you what you're gonna type next, or maybe it's a single line or like a whole snippet of code. And we train our own models from ground up. And we do this because we care a lot about data privacy, using the right licenses, and so on. And I believe the main challenge for us is currently, I think, in general, so we can do a lot of things that we haven't done yet and improve our models in general and ensure we provide the better solution for code completion on the market. But also, I think an important challenge for us is to understand what the users actually need from the completion, because there are different types of users. Some want very brief and straight to the point completions. They just extend standard lookup that existed in IDs for like, for 20 or so years. And other types of users want actually smart completion that just suggests you, half of the file, and you just type something, get the whole program, completed. And often these groups of people are very conflicting in what they want, and they want radically different things. And we need to somehow balance between these types of user experience, and it's kind of tough for us.
Okay, thank you.
Yeah.
Anything else to add? Sorry, I interrupted you.
No. I answered all the questions you wanted me? Yeah.
Thank you very
Great.
much, guys. It was a great intro into your specific projects. So the first topic that we had on the agenda was, before we move into how to train the models, how do we evaluate? So what is the benchmark we measure against to see whether actually the model performance improves or doesn't improve? So can you briefly talk about because you, as Nikita rightly mentioned, you're sort of involved in same field but you're solving different tasks. So presumably the benchmarks that you're using are sort of different. But how we go about this is the publicly available benchmarks are enough. SWE bench is all you need, or do you collect internal ones? And what are the pros and cons of this of different approaches? So we're gonna start with Alex. Thank you.
Yeah, thank you. So once again, since I'm working on classic like chat-like interface LLM model, so I will split the expectations of this model once again in 2 parts: code generation and basically everything else. And even this second part could be actually split into still software-related tasks involving code and the ones that don't involve code, like, as I mentioned, some generic questions about some utilities, tools, or something like that. And we have quite developed set of benchmarks. So yeah, we don't utilize any open source benchmarks. As far as I know, we use some of them for our pre-training ablation models, pre-training models ablation before post-training, but an actual setup of actual like chat assistant in IDE, this is for some reason is so unique. Not like it sounds that it's quite boring, but at the same time, all the open source benchmarks and many other open source just publications, articles, they focus specifically sport programming or some like isolated coding challenges that are quite artificial compared to real life day-to-day job of software engineer. Yes, I'm aware of few quite good benchmarks that I would actually can admire. Yes, for example, yes, SVE bench or ADER bench, but actually that's kind of it, like that comes to my mind. And since there are not that many benchmarks in open source, we've developed our own set of benchmarks internally. And first of all, one main of them involves code execution. Internally, we have a system which allows us run tests in real life repositories, projects at large scale. So we have parsed lots and lots of open source projects. I mean, like projects like from GitHub and other similar platforms with permissive licenses, of course. And we able to launch real tests from them, from theirs. So we're able to reproduce this environment with the same tests, with the same linters, etc. So in the end, our main benchmark is we generate code solutions for code generation tasks, and we launch existing tests on from real life repositories, and we cover by that, like by the set of the prompts we're using there and repos that we're using there, we cover most popular languages, and we cover actually quite many different scenarios by that. If we dig a little more into details, that yeah, we specifically like the biggest probably disadvantage of such approach is that the prompts that we're using there is synthetical. We generate our data sets that way, so we can, in the end, we can validate a solution for such task with existing test sets, test cases that already were written by real engineers there. Second disadvantage of this benchmark is the fact that actually open source projects are not really well covered with tests. And it's quite a challenge to measure real test coverage of the code base. But that's not the only benchmark we're using. I'd say it's the main one. But also, as a second aspect of our quality is what we may call like robustness. The difference is that if it's not just some artificial or like scientific paper where you're just working on the numbers, but it's real life too, you want it to be really robust in the sense that if you know that this model can actually solve this task, it should robustly generate solutions, ideally like 100%. No matter how many times you press the button regenerate or the way you reformulate your prompt, it should be able to generate correct solution. And since this task actually involves structured outputs generation, since we have to generate the real diff to the existing files, we are not just like a chat application. We also have to change the given file. So many steps where things can go wrong, and this means that the model should be really robust. So the users at least after some experience, will be able to develop the intuition inside the intuition on how, like, what kind of problems model are actually good at, what are still better to solve by yourself. And in addition, like, my final item is that we have, as I said, other scenarios, and internally we're trying to cover the quality of them by what we may call like LLM as a judge or reward model as a judge benchmarks, where we have some set of prompts, diverse set of prompts that cover interesting scenarios, and we validate the quality of that of the answers in those scenarios by some another large language model. Yeah.
Do you specifically fine-tune this model to be critic in this case, or just use it as it is?
We use several models. Yeah, we have our own specifically developed for some like, for example, we can fine-tune the model to predict code test outputs. Like, if you don't have tests here, you can predict tests. And oh yeah, I forgot to mention that in such set of prompts on which we do LLM judge validation, we also have code generation tasks too, because this test set contains only like real user logs. I mean, not user logs, but the requests that are written with users with the help of human, but not generated synthetically. So, for example, yeah, we have a model that can predict the code correctness better than some just prompted LLMs judge. But in other generic cases, we use existing other models that allows us to cover a lot of other different scenarios. Yeah, thank you.
Okay, thank you. Boris, we were going to follow the same sort of sequence. You're next. So talking about the benchmarks, what kind of benchmarks you're using, pros and cons, where do you get them? Is everything that is publicly available enough, or doing something specific?
Sure. So as I've said before, we're working on this agentic systems that take problem description and def environment as an input and produce a patch as an output. So if we want to directly measure the performance of such a system, we need a benchmark that is structured in exactly the same way, like a bunch of tasks with def environments and descriptions of what needs to be done, with some way to verify whether the some patch that the system produced was correct or not. And currently, like, the kind of go-to benchmark catering for such cases is SweBench, that has been mentioned before today. I think I should explain what SweBench actually is and how it was built, so that I can explain why it might not necessarily be a very good benchmark and what can be improved in it. So SweBench is a benchmark that has been created by a group of researchers in Princeton, and they've used the following methodology to collect it. First, they kind of selected a bunch of popular Python repositories with a permissive license on GitHub, and I should mention that this benchmark caters specifically for Python, but the same methodology can, in principle, be used to build similar benchmarks for other languages. So they've selected a bunch of these Python repositories, and then they took all the kind of issues that has been opened on GitHub for these repositories. And some of these issues have been resolved with a pull request. So like, someone has submitted a pull request to this issue, and after this pull request has been merged, the issue has been labeled as resolved, which kind of hints at the fact that this pull request might have resolved the issue. So they took these issues that kind of ended with a pull request, and then they took only those pull requests that have added some tests. And the idea is that if you have added some tests, then these tests are probably tested the new functionality. So maybe you can use them to test your patches too. And so basically what this benchmark is a bunch of this kind of dev environments description that was taken directly from the GitHub issue, the tests that have been added in the canonic solution, and you can generate your own patch and test it again against the same tests. And if it passes, then your solution is considered correct. So now there are some obvious issues with this approach. Like the first issue is, what if the description was not well defined enough? And by that I mean it was kind of underspecified, and you actually need, like someone actually needed more information to implement the solution, and maybe this information has been communicated via other means, not through like GitHub issue, but maybe through direct messages or something like that. And we don't have that now. So we cannot like properly implement the functionality just based on the description. And the second issue is tests. So this assumption that tests from the canonic pull request can be used to validate any patch often breaks in practice. And the reason for that is that tests might be too specific, like making very particular assumptions about how the code that solves the issue is structured. And these assumptions aren't actually reflected in the issue description. It's just some choices that the developer made, and then kind of tests reflected those choices. So how can you go about resolving these issues? So one attempt at doing that is something that is called SweetBench Verified, which is a subset of SweetBench benchmark that has been curated by OpenAI together with the SweetBench team. And the idea is that, well, basically they verified a bunch of tasks using like actual human software developers, asking them exactly the same questions. Is the description kind of well specified? Are the tests not too specific? And so on. And they've selected 500 problems from the original SweetBench that adhered to this kind of constraints, and this benchmark is supposed to be 100% solvable, and it is definitely better than the original SweetBench. Some problems have been found in it already, but I think it is close to being 100% solvable. And one final issue with it is that it only covers like fixing kind of small, well, it mostly covers fixing small bugs and implementing new small features, because that's what kind of issues usually are on GitHub. And it doesn't cover things like implementing a huge new system from scratch, or maybe doing a code base wide refactoring. It's not very clear how to automatically measure the quality of this changes, because it's very ill-defined, but at least we have a reasonable way to automatically measure if we can fix bugs, which is already something. And yeah, basically currently we are using SweetBench Verified to test our system.
Do you think it's a problem that even the verified benchmark is sort of skewed towards Django, I think, library versus some others?
Oh, it definitely is. It contributes a lot into the variance of evaluations. Like, well, let me put it this way. So agents are generally, at least the current generation of agents, has like very high performance variance. Like you run it once, it solves something. You run it next time, it doesn't. So it adds a lot of widths of the error bars to your evaluation results. But when your benchmark set is skewed, like I don't know, a third of it is Django or something, it adds to variance even more, because like if you make a very particular mistake that for some reason affects Django more than the other stuff, your quality just like drops suddenly. So you'd want this test sets to be large and to be as kind of diverse as possible, so that your evaluations are actually precise.
Okay, thank you, Alyosha. I see your hand, but Nikita is next, so we can gonna go do a quick Q&A after Nikita closes with his. remarks about benchmarking at JetBrains?
Sure. Okay, I'll start with the how you can generally evaluate code completion, and it seems from the first glance that it's quite easy in the idea. So you take some code, remove a chunk of code from the code files, ask the model to complete it, and compare if the completion is similar to what was originally written in the deleted chunk. But you quickly discover that this approach is flawed in many ways, because, for instance, it's not always the case that your completion should match identically what you deleted. So, for instance, sometimes it's better to complete a single line and let the user to review one line, and then maybe the user will decide what they're gonna do next. And you showing just 100 lines piece of code, and it's quite useless for the end user. And the second, I think, flaw is that usually we all stick in some sort to open source data, and open source data may be very different to what you actually get in the production. It is especially true for other languages than Python, I suppose, because, for instance, we JetBrains are famous for doing stuff with Java, and Java in open source is like radically different from Java with the enterprise in real companies. So like two different Java worlds, and like and also this true for Kotlin, for instance, and especially for Kotlin, we noticed that we, for example, improve the quality on open source data, and we decrease quality on our internal code base. So because they're radically different. And for code completion is also it is also quite hard to get the open source data, because the setup is also different. If you take just open source, just random file from a GitHub and delete a chunk from it, with the completion you'll get the finished result. So this is a finished file that somebody committed to GitHub. It's not how you work with when you're writing code. So when you're writing code, you have nothing. So maybe you have a lot of synthetical errors when you type something. So yes, you still want to get completions, and there is a huge, I think, distribution shift between the stuff you see in the open source or just online and what the user actually send to the completion service. So we kind of try to use still open source data, but try to modify it in a way that it looks more similar to what you get in the real world. So we have specific modules that try to extract, for example, I know function names, function contents, and stuff like that, and try to remove the specific chunks and simulate work in progress stuff. That you also, the metrics are tricky, because you can measure the similarity. Maybe you want to also measure the quality of the completion code itself. So sometimes, usually code on the GitHub, for example, is not perfect. It is very often, has significantly worse quality than you expect in the industry in some open source projects. So you want to judge also how good the completion is. You want it to be, perfect, and it's sometimes quite different to what is actually written in the ground truth. So we also use some automatic like evaluation through LLM as a judge, and I think, looking into the code execution stuff to evaluate if the completed code is actually correct. And we also can measure it on the client side sometimes, because JetBrains ID are constructed in a way that you need to configure your environment to run anything. So we kind of can trust the client side here. And finally, I think I first one who mentions it, but we have some users in the JetBrains AI product, and we can measure online metrics that are super valuable for us. So, for instance, we can measure get the signals, how often users accept our completions, which fraction of code, for example, in their code base is written by pressing tab. And this is super valuable feedback that we try to actually target here. So that's kind of it.
Okay, thank you very much. Aleksei, conscious of time, I would like to move to the next topic, which is probably the most interesting. So guys, when we discuss how you measure the performance of your models, let's now talk about how you do the post-training bit. So well, I think everyone is interested in as to not just whether it's, SFT or LHF, how does the whole, pipeline look like, where the data comes from, all these sort of insights that you can share with us of how how does the system looks like that how you do which you use to train your model. And Alex, we go with you.
Yeah, thank you. So as I mentioned, like my project have a lot in common with classic large language models. So yes, we have all this classic stuff like SFT, RLHF, and so on. But yeah, what do we do specific for coding is, yeah, we actually utilize a lot synthetical data generation. We also use human annotation, but like I'd say we use human annotation for additional filtering of the data to make it even more clear, or in some cases we gather data sets to train additional, we can call it reward model, just like some classifier of the quality that in the end we use for data set preparation. And so yeah, code generation is actually really wide topic and very wide domain. So we can have actually very many diverse tasks that people actually do. And we have many different data sets there, but we can split them into like horizontal and vertical by the idea behind it. So for example, horizontal, like our main source of data, code generation data is synthetical data sets that we generate based on commits from existing open source projects. So how I do this, if we simplify this, then we take commit, we take some changes, we take changes from this commit, and we then look at the tests, look at the changes, and at the end somehow we combine the we don't utilize the commit as it is. We construct like a subtask out of it, because actual commits sometimes, like I'd say on average, they're quite large. It's multiple files with multiple changes that are not actually maybe they maybe accidentally appear to the same commit, but they are not. They don't have any semantical similarity in common. So we construct some task out of it. Then we do what we call back translation. Basically, yeah, we generate synthetical, use like query from such task with tests. And then we do reinforcement learning loop where we utilize existing models that somehow can generate code, and we generate solutions for that synthetical tasks. Then we run existing tests on them. Then we do additional post-processing filtering on correctness, first of all, code correctness, because as I said, sometimes more existing tests are not enough. And also, if solution is not passing test, maybe it may be actually correct, but it's more rare case. Then we also look at the quality of, so yeah, I forgot to mention that our model produced, like it has two parts of the answer. First is classic like markdown answer with like text that is presented to user, and second part is structured output, which in the end allows us to change the file. And code execution is more or less evaluating only this second part, but we also need to validate the first part. Yes, and we validate this with reward model and additional heuristics. But also we construct horizontal data sets, which or for example, it may be like we come up with some particular idea of some particular use case that user might do, like bug fixing. For example, we know that it's quite common case when user just copy paste some step trace, some error that he's facing, and it's all like very ad hoc, and like we come up with particular bespoke pipelines for these tasks to generate specific narrow task data sets. And yeah, we have many of them. What else? I think, yeah, that covers most of it. I forgot to mention that one of the actual real challenge in code generation is multi-turn, and main part of like multi-turn, meaning like user may not only give the model only single command, model generated some answer, user then gives some additional follow-up question, or actually it gives some feedback to the model saying like, come on, this is incorrect solution, change this and this. And models, like out of the box, like just pre-trained models, they all really struggle with admitting their own mistakes and fixing them. Actually, if you really use a lot, even like some more popular models like ChatGPT or Claude or something else, you may see this too. Like they're quite good models, but this particular scenario where you ask the model to really fix itself, fix its previous answers, and if you do this not only once but multiple times in dialogue, this like error is accumulating exponentially. So the successful rate in the end is quite low. So we have specific pipelines based focusing this particular aspect of the quality. First of all, it kind of the same, but we now solve the task in multiple iterations. Like if model is incorrect from the first attempt, we give it some feedback back in different ways. We can reformulate this feedback. We can just copy paste the stack trace of the tests, and then we'll launch again. And we try to squeeze this loop, like feedback loop, in shorter answer to then teach our model to produce correct answers more often from the first try.
There is a question for you here. So which LLM model variants do you use as baselines for the downstream task? I think you can read this as is, I mean, whether you use open source or build your own ones. Maybe I'm reading this wrong. But again, LLM models variants do you use as a baselines for the downstream tasks?
So yeah, I mean, as a downstream task, we may mean some intermediate tasks that we are actually solving in our synthetic data generation pipelines. And we mostly use our own models, but we also use open source models with permissive licenses, of course, for some to get more diversity, to explore. Like if we may talk about reinforcement learning, of course, want more and more diversity in your data, because if you like, there are some side effects like not catastrophic forgetting, but mod collapse when, for example, if you generate synthetic data sets with only one model and you don't care about diversity, then all the following attempts on this like reinforcement learning loops where you try to come up with and discover more and more solutions for more and more complex tasks, they will fail. So yes, we utilize other open source models, usually the best that is there with permissive license at this time. So for example, yes, we now also use Qwen models for some intermediate tasks, but most of the time we use our own models.
Okay, thank you very much. Conscious of time, Boris, we're going to have this discussion. We could have a discussion after this. But Boris, you're next. So can you describe how the training sort of pipeline looks like, where the data comes from, and stuff like that?
Sure. But before I do that, I think I should actually need to explain what we actually do, because otherwise it wouldn't make sense. So as I mentioned before, we are interested in kind of applying search methods to these agents, and I need to explain what that means and how a typical agent looks like. You can think about an agent as well, one simple example of agent is this. Imagine like a for loop which says something like that. While not done, ask some large language model what to do next, execute the command, add the command and command output to context, and kind of repeat this process. So just repeatedly ask the LLM what to do next. You can, run this agent once. It will produce some result. We call this unrolls. That's what they call them in reinforcement learning. So that's how a typical agent works. So what we're trying to do is we are trying to analyze the space of all these possible unrolls and kind of figure out maybe at some point we should have taken a different action and followed a different path, and under some compute constraints, kind of try to explore as many of these paths as possible. And to do that, having one model is not enough. We'd actually need two models. So the first one is the LLM that produces these actions, which we call action generator. And the other one that we train is something we call a critic model, which is kind of similar in spirit to reward models used for RLHF, but a bit different. What it does basically is it takes a state that an agent is in as an input. So basically what commands has the agent issued so far and what were the outputs of these commands up to a particular point, and then tries to estimate the probability of success if the agent were to continue from this point. So basically it's a model that predicts the probability of success continuing from any state. And training this model is actually relatively simple compared to training action generator. So what you need is a data set of trajectories of your agent kind of solving or failing to solve various problems. And if you have this data set, you can kind of set up the problem of training the critic as a supervised learning problem where your data points are basically all possible prefixes of the trajectories, and from those prefixes you kind of trying to predict whether something will be successful or not. So if you set up the loss correctly, what you will learn when kind of solving this problem is kind of expected probability of success starting from a particular prefix. You can apply a bunch of different tricks from reinforcement learning on top to make this process more sample efficient, use things like bootstrapping, but like kind of overall, it's basically simple supervised learning. So we also, although kind of our search methods can be applied to frontier models such as GPT-4 or Claude Sonnet, we also train our own action generator just so that we can do experiments with in-house models and kind of reduce the cost of experimentation at scale. So we need to train our own action generators, and it is a bit more involved, to be honest. Like we've tried many different things and eventually converged on a very ad hoc pipeline, which I think is in many ways suboptimal, but that's what currently works best for us empirically. So basically, again, we have this data set of positive and negative trajectories. And kind of the simplest thing that you can do is to just take the positive trajectories and do supervised learning on them, kind of learning to imitate just successes. But if you do that, what you will discover is that some of these trajectories have mistakes in them, like poor actions that shouldn't have been taken, but somehow an agent later managed to recover from its poor choices and eventually solve the task. So if you do supervised learning on that, you will learn to imitate the errors that the agent made as well. And the funny thing is, like, imagine you have some action generator. It's imperfect, so it makes mistakes, say in 5% of the cases, it chooses a poor action. But then you train this action generator on data that also has like 5% of mistakes, and it will do kind of its own mistakes, but it will also learn to imitate mistakes in the data. So like it's kind of the error probability of the new iteration will be more like 10%, not 5%. And if you continue this bootstrapping process, the error probability will grow and grow and grow, which is not ideal. So what we've learned is that one thing you can do to avoid that is kind of mask out clearly poor action choices in the trajectories. So never learn to predict them in a similar situation, but still put them into context. So basically, we're not forcing the model to take the same actions, but we're still learning that if this action has been taken for some reason anyway, what's the correct way to recover from this action? Unfortunately, we don't have like a readily available labeling for what action is poor and what is good. we can use our critic model to actually kind of try to label them, or we can use a bunch of heuristics. Like if some action led to I don't know, an error from the environment, like failed linter checks or something like that, then it was probably a bad action. So we do stuff like that. We also found it very useful to use bad trajectories that don't resolve the task as well, because they might have some good pieces. Like you can imagine agent successfully reproducing the bug that it needed to fix, but then failing to fix it. You can still use the reproduction part and benefit from it. Again, unfortunately, you don't have like a readily available labeling which part of the trajectory was good and which wasn't. So you have to use some other models to kind of relabel the trajectory and figure out how to train from it. And we also have like a lot of, so for a single problem, we would have a lot of different trajectories solving it. Some would be better than the others, some would be very similar. So it's very important to do kind of rebalancing of this data set, duplicate the trajectories, try to learn from the best trajectories and not from like very questionable choices and so on. So all of this helps to some extent. And if you combine all these techniques and train, I think most recently we've been using Quen 2.5, 70B as the action generator. If you kind of combine all these techniques, then it quality well almost reaches kind of GPT-4o quality on this particular task. And it's probably not the limit. I'd like to say one more thing about it. So what I've just described is very unprincipled pipeline, like very ad hoc heuristical, and the right way to go about it and to learn from like a mix of positive and negative trajectories is probably by using offline reinforcement learning. The problem is that we so far we haven't managed to make it work better than our ad hoc approach, but like in theory, at least, if we kind of overcome all the issues, it should give the best results.
Thank you very much, Boris. Again, conscious of time. Nikita, you're up.
Okay, so actually the term post-training, I think it's not really well defined in the industry now, so it's kind of hard to call something post-training. So, but I will just, I think, describe how we train our models in general. So without, you know, sticking to the post-training term. So first we pre-train our own LMs on just a lot of open source permissive code. So we do this instead of taking open source model first, because we want to ensure that actually the data is, you know, correct and we can use it. So we cannot be sure about open source models. I think is generally the problem of open source. So even if, for example, authors claim that they train only on super permissively licensed code, you have no way in verifying it. So this is the main problem, but other than that, open source is great, and I think we could theoretically think about taking the open source model if it wasn't so important for us. But still, I believe we can deliver better than open source. So just my humble opinion. And so after the model is trained, we perform a lot of fine tunings for the specific, like our completion use case. So from the general purpose code model pre-trained LLM, we make a actual completion model. So we focus a lot on fill in the middle task, for example. So the model should be able to fill the code. So in the middle of the file, taking care of both what is above cursor and below cursor. Also, it should take into account the context, like files relevant to what you need to complete and stuff like that. And after finally, so when we have this model, it is already quite good to, you can deploy it, for example. But actually, I noticed that I also have a dog, and I also noticed that training LMs and training a dog to perform some commands is very similar, because they both try to cheat in you know, in all possible ways. So for instance, I think I throw one particular example that I find funny. So for instance, if you ask a model to complete something in the middle of a file, it can actually write you a comment saying to do. It's kind of hard. It is a correct code. It's just synthetically correct code. It is a comment. It is quite often, you can see it in open source, and it kind of makes sense from the statistical perspective, but it really annoying, and it's like super useless to actually show these completions in production. And a lot of this stuff that called post-training, I believe, is also focused on removing the undesired behavior of a model. I think in general, LLM world is something closer to safety, I think. So safety is kind of similar in this fashion. So, and we have a data set of a lot of different undesired behaviors that we experience in the completion models. And we use some techniques similar to LHF, I believe, but not on the actual human feedback for now. So it consists, of these corner cases and some general pairwise annotation of different completions. And also it is, I think, connected to, I now realize that I forgot to mention one very important type of benchmark that people, I think, want to drop somehow and not talk about it seriously, but we all are engineers here, and we develop tools for engineers. And so you're your target audience, and you can actually go and look at what your model produces and try to use it in your everyday work. And quickly, if something goes wrong, you will quickly notice it. So, for example, this is how we came up with this to-do use case. So you just try to type some code, throw something in the model, and realize that something you really hate about it, and try to fix it. So I think our data set is largely constructed in these use cases that I for example, personally hate from the model. Yeah, and some general pairwise annotation. So I believe, I quite brief here. So
You mentioned in the
that's
previous
kind of it.
you mentioned previous that you have the advantage of getting the users' feedback. So how do you implement somehow this user feedback on a model?
Unfortunately, so I get your question. So it is we theoretically could implement it, but we don't, because one of the things we put, very upfront in our products, and actually something that we are proud of, we care a lot about privacy. So nothing that goes into, the AI assistant is not like saved anywhere. So we cannot actually so as an ML engineer, I would really like to use this data because it's like super valuable source of stuff, but we cannot, and we are committed about not using it. But I'm thinking about using, for example, our own completions and our own feedback. So, and we actually use it in training, because I'm okay, I'm just championing using my code in the completion, because I think my code is great and the model should really see it and learn something from it. But yeah, unfortunately, online feedback is kind of hard to use if you care about privacy.
Okay. Yeah, I think we had just had a question about the feedback from users, and I think you just answered exactly that. So conscious of time, we have only 1 minute left. Maybe there are any other thoughts you'd like to share about the training of the models. Please feel free, or I open sort of for you the question of what comes next. What should we expect in the future, in the coming months? Probably in the coming months rather than years, because everything changes very quickly. So what is the next sort of milestone that we should expect in the market?
So yeah, maybe I can share my first humble opinion, as Nikita said. For me, so I also find the stream of agents is very promising, and it's like I really observe how rapidly it's being developed, and we will also work, and we actually started working on this also inside poolside. But from somebody outside this domain, it may you might think of the agents like they will replace everything else, but actually like agents, for example, will never replace code completion. You will still write code and you will still need this tool. And it's like, for me, it's like if you use code completion to save seconds, you use chat to save minutes, and you use agents to save like hours, for example. And yeah, I'd say that we will definitely see agents as a day-to-day tool that every engineer will use. Also, we see more and more, like I forgot to mention, yes, that main go-to-market strategy for poolside is running on-premise, completely private installation for enterprises that also being like inside that we fine-tune our models on the code of the client, which is completely done on the on-premise, on the hardware, or in virtual private cloud or some similar infrastructure. And the market is organized that way, that main like sadly or happily, most of the software engineers, they work in large enterprise companies, large banks, large, yeah, I don't know, governmental structures, and they all require additional like level of security and privacy. And if you think of this from engineer perspective, it's very interesting and challenging task to make it work as best as possible for this particular given set of repositories, for example, of this particular given use cases that they have. Like, it's quite different from what just making good model in general. So this may be quite a hot domain in this market.
Thank you, Alex. Nikita, Boris, do you have any other thoughts on what comes next?
I mean, I definitely expect that agents will become like a big thing. I would imagine that the workflow of an engineer will kind of slowly transform into something like this. So people would start kind of delegate into agents more and more stuff. So they already can do like very simple things, and these things kind of become more and more complicated with each passing month. And like currently we are mostly writing all of our code, but I would imagine us slowly transitioning into kind of more and more describing what we need to do, like creating a say GitHub issue, then some automated system that watches this issue, submits its proposal for pull requests, and you review it. Maybe you're satisfied and you accept it. Maybe you provide some feedback, and the system reiterates. Or like if it is a very complicated thing and you understand that the system will fail in any case, then you open your favorite code editor and kind of begin working. So like basically every engineer will kind of slowly transition into tech lead / engineering manager, and we will observe it in the coming year or a couple of years, I think.
Thank you. Nikita, do you have any thoughts on what comes next?
I think I mostly agree with Boris. I have some hot takes on all the agents and stuff. So I'm not sure. I'm not really personally sure how close are we to useful agents. But I must admit that I think it's a natural way of developing the AI. So maybe in a month, maybe in a couple of years, I think agents will be a huge thing. So because I think I'm mostly satisfied definitely with code completion and with the general chat stuff. So I think it works really great and kind of solves a lot of everyday problems. So I don't see like a dramatic change in this field. So it is already working good enough. It can definitely be better in general, but it won't, turn anything upside down. And agents, I think it's kind of a whole new thing that is not here yet, definitely today, because I haven't found any really practically useful agentic tools that I would use on everyday basis, for example. But I think they will definitely come out one day and quite significantly change the workflows that we are used to right now.
Thank you very much. I think we're 6 minutes over time already. I would like to again say thank you to Alex, Boris, and Nikita for joining us today and talking about this. I see a couple of questions in the chat that I'm probably trying to quickly skim. I think there was a question about transfer learning. I think the colleagues already told us that, yeah, it's part of they do use open source in some cases. They do fine tune all open source, but they also train the models from scratch. So yeah, there is some definitely transfer learning in some cases. We answered about feedback from users. So about synthesizing audio, and I think this is not the area of expertise of sort of these colleagues of ours, but there are companies that are doing that. So basically, it's a slightly different task, as I would imagine. And there is safety issue. I don't know. Do you want to any of you want to comment on the safety issue? So the question is, how do you make sure that the agents or the models that work in code produce safe results? Maybe let's narrow it down to make sure that it's not safe in terms of traditional, not suitable for work sort of stuff, but in terms of code security. Do you ever think about this? Is it part of the equation? As in producing the code that doesn't have vulnerabilities, producing suggestions that don't have vulnerabilities. Yes, Nikita.
I think I remember some efforts in open source about making the whole code generation stuff safe. For instance, as far as I remember, in StarCoder 2, for instance, the authors tried to filter the code on GitHub to find malwares, and they actually found some. That was surprising to me. So there were actual malwares on GitHub, and for instance, if you just blindly train the models on just any code you can find, your code will definitely have vulnerabilities and it can actually produce malicious code. So and it's kind of funny, but I think it's something that we consider. So, but anyway, I think they are coming from somewhere, and the model trains on data containing vulnerabilities. So probably some data filtering should be implemented to reuse the stuff from this kind of safety standpoint.
Okay. I think that's all. Thank you very much, Nikita. Thank you very much, Alex, Boris, as well. It's 8 minutes past. Have a great evening, and thank you for joining today.
Thank you. Bye.
Everyone. Bye.
Bye.